Hello students, welcome to PUC classes. Today I am going to starting with the new chapter, one of the important chapter of our first PUC Mathematics, that is sequence and series. In this, what is the sequence? Sequence is an arrangement of numbers in a particular order, or it is an arrangement of numbers according to some definite rule. For example, 2, 4, 6, 8, 10 and so on. This is one sequence. In this sequence, we are collecting some objects or some numbers in a particular order. So, we are all listed the numbers 2, 4, 6, 8 and 10. They have some order. This is the one sequence. In this sequence, we use some orders, that is 2, 4, 6, 8 and 10 in here. First number is 2, second one is 2 into 2, third one is 2 into 3, fourth number is 2 into 4, similarly 2 into 5 and so on. This is the one sequence. A sequence has some definite order, particular orders. That is, first number is 2 into 1, second one is 2 into 2, 2 into 3, 2 into 4 and so on. Here, these are the numbers or objects of the sequence. It's having some order. That order is 2 into 1, 2 into 2, 2 into 3, 2 into 4 and so on. These are all the terms of the sequence. These are all these numbers of the sequence are the terms of the sequence. This is the first term, this is the second term, this is the third term and similarly the fourth and fifth and so on. What is the terms? The various numbers occurring in the sequence are called the terms. The various numbers occurring in the sequence, that numbers are the terms. That numbers are called the terms. This is the first term and this is the second term. This is the third term. We easily identify the members of this sequence. This is the first member. This is the second member of the sequence. This is the third member of the given sequence. For example, we have to take on the example 2, 4, 8, 16, 32 and so on, 24. This is also one sequence. It's having some particular order, that is 2 to the power 1, 2, 4 is 2 to the power 2, 8 is 2 to the power 3 and 16 means 2 to the power 4, 32 means 2 to the power 5 and so on, 2 to the power 10. This is the one given sequence. This sequence having a particular order. That particular order is 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4 and so on. We will take another example. 1 divided by 2, 2 divided by 3, 3 divided by 4, 4 divided by 5 and so on. This is also one sequence. In this, the sequence having some terms. This is the first term, this is the second term, this is the third term. In general, we have to denote the terms are A1, A2, A3 and so on AN. A1, A2, A3 and so on AN. The subscript indicates the position of the terms. The subscript 1, 2, 3 and so on N. This indicates the position of the terms. If the terms having the n numbers, though that is an, so n is the nth nth position of the sequence. Also, it is an is the general form of the sequence. An is general form of the sequence. General form of the sequence. Okay. If every sequence having the general forms, the first sequence is a 2, 4, 6, 8 and 10. The general form of this sequence is just it is on order having the 2 into 1, 2 into 2, 2 into 3 and so similarly this is the nth term is written as a first term is a1, second term is a2, third term is a3, fourth term is a4, fifth is a5 and so on. The nth term is an. So the general form of the given sequence is an is equal to 2 into n. The given sequence, the general form of the given sequence is an is equal to 2 into n. If here n is the set of natural numbers, so an is equal to 1. First term is 2 into 1 is 2, 2 into 2 is 3 and so on. Similarly, the nth term is 2n. In the second example, this is the one sequence having the numbers 2, 4, 8, 16, 32 and so on 1024. So it's having some particular order, that is 2 to the power 1, 2 to the power 2, 2 to the power 3 and so up to the 2 to the power 10. So in the general form of the second sequence is an is equal to 2 to the power n. The general form is an is equal to 2 to the power n. The nth term is also known as the general form of the given sequence. So an is equal to 2 to the power n. If the n is the set of natural numbers, we are using that natural numbers. 2 to the power 1 is 2, 2 to the power 2 is 4. Similarly, as so on, 2 to the power 10 means 1024. Here, last one example, 1 divided by the is our sequence 1 divided by 2, 2 divided by 3 and 3 divided by 4. This is having some common order, that is 1 divided by 1 plus 1. 1 divided by 2 is also written in the form of 1 divided by 1 plus 1. Similarly, second term is 2 divided by 3 is also written in the form of 2 divided by 2 plus 1. Similarly, third term is 3 divided by 3 plus 1. So 1 divided by 1 plus 1 is 2, 2 divided by 2 plus 1 is 3, 3 divided by 3 plus 1 is 4. In the similar way, the nth term is also written in the form of n divided by n plus 1. So an is equal to n divided by n plus 1. Similarly, 1 divided by 1 plus 1, 2 divided by 2 plus 1, 3 divided by 3 plus 1. Similarly, the nth term is written as an is equal to n divided by n plus 1. So the nth term is known as the general form of the sequence. In the sequence, there are some types. So first one is a finite sequence. What is finite sequence? Finite sequence means a sequence which contains the finite number of objects or elements is called the finite sequence. So, okay. Finite sequence is a sequence which contains the finite number of terms. So that sequence is called the finite sequence. For example, so 2, 4, 6, 16, 32 and 1024. The sequence we know the terms of first term and the last terms. This sequence is called the finite sequence. This sequence is called the finite sequence. Finite means a sequence containing the particular numbers of the terms. For example, a1, a2, a3, an numbers. We know the numbers of an. An is the nth term. So, for example, it is containing the nth term. So 2, 4, 6, 8, 16, 32. It is a finite sequence. It is a finite sequence. Okay. Next one is infinite sequence. Infinite sequence means a sequence which contains the infinite number of terms. A sequence which contains the infinite number of terms. That sequence is called infinite sequence. That sequence is called the infinite sequence. For example, 2, 4, 6, 8, 10 and so on. The sequence containing the numbers, but we know the first term also only. We do not know the last term. So this is a infinite sequence. Means a sequence having the infinite number of terms. A sequence having the infinite number of terms. That sequence is called the infinite sequence. So, infinite sequence is having the successive terms of various numbers. Successive terms. It does not contain the ends. It does not have any ends. So, that sequence is called the infinite sequence. So, infinite sequence is the successive. Having the successive terms. It does not have the ends. Okay. Next one is a Fibonacci sequence. What is Fibonacci sequence? Fibonacci sequence means it is an arrangement of numbers which has no visible patterns. It is an arrangement of numbers which has no visible patterns. For example of Fibonacci sequence is 1, 1, 2, 3, 5, 8 and so on. This is an example of Fibonacci sequence. Fibonacci sequence means it is an arrangement of numbers which has no visible patterns. Here in the Fibonacci sequence, first and second terms are same. This is the term A1, this is the A2, this is the term A3, this is the term A4, this is the term A5 and so on. So in the Fibonacci sequence, first two terms are same. So A1 is equal to A2. In the Fibonacci sequence, first two terms are same, that is 1. So A1 is equal to A2 is equal to 1 and the third term A3 is equal to, third term is 2. So it means sum of two preceding terms. Sum of two preceding terms means A3 is equal to A1 plus A2. A3 is equal to A1 plus A2. A3 means it is the third term. The third term is sum of two preceding terms. So there is A1 plus A2 is equal to A1 is 1 and A2 is 1 is equal to 2. So third term is 2. Similarly, fourth term is A4 is equal to A3 plus A2 plus A3. A4 means sum of two preceding terms. So A2 is equal to 1 and A3 is equal to 2 is equal to 3. So fourth term is 3. Similarly, A5 is equal to A3 plus A4. A3 is equal to 2 and A4 is equal to 3 is equal to 5. So fifth term is 5. Similarly, nth term is An is equal to A of n minus 2 plus A of n minus 1 if n is greater than 2. This is the general form of the Fibonacci sequence of the given sequence. So An is equal to A into n minus 2 plus A of n minus 1 if n is greater than 2. Because if n is greater than 2, because first two terms are same, this is applicable for the third terms and similar to the continuous terms. So An is equal to A into n minus 2 plus A of n minus 1 if n is greater than 2. Alright, so this is the Fibonacci sequence. In the Fibonacci sequence, first two terms are same. After next, the third term is sum of sum of preceding terms. Similarly, fourth term is sum of preceding two terms. Similarly, in the same way, n term is equal to an is equal to a of n minus 2 plus a of n minus 1. This is the Fibonacci sequence. So, next is a sequence as a function. Sequence gets as a function which domain is a set of natural numbers or subset of the natural numbers, which codomain is set of all real numbers. Set of all real numbers. The sequence of the function is known as a of n for an. A functional notation of the sequence of the function is, this is the functional notation of sequence of the function a of n for an. A of n for an. So n is a subscript. This shows the position of the sequence, terms of the sequence. Okay. A sequence of primes. A sequence of primes. A sequence of primes are 2, 3, 5, 7 and so on. These are the sequence of the prime. This sequence, it does not contain in the general terms. It does not contain in the general terms. This type of such type of the sequence only described by the visible description. Described by the visible description. So, we have the, it does not have the any general terms. Okay. Next one is series. What is a series? Series means it is the sum of the sequence. It is the sum of all terms of the sequence. So, let A1, A2, A3 and so on an be a given sequence. Then the expression A1 plus A2 plus A3 plus and so on plus an is called series. Series means it is a sequence. It is one of the sequence. The sum of all the terms of the sequence is called the series. Series means it is a one given sequence. The expression A1 plus A2 plus and so on plus an is called the series. Okay. Yes. In this series, a series is a finite or infinite. It is completely depending upon the given sequence is or corresponding sequence is a finite or infinite. Corresponding sequence is a finite, though then the series is finite. Then the corresponding sequence is infinite. Then the series is infinite. So when the series we have written represented as the compact form or sigma form. The series are represented as compact form or sigma form. The sum of a k. So k is equal to 1 to n. So this is a summation. Summation means sum of all the terms. So ak is a general form of the given sequence. So k is equal to 1 to n. So the base is represented in the first term and the top is represented as the last term. So ak is the general form of the sequence. So this in the series, so ak is sum of ak running from 1 to m. 1 is the base, so initial term means first term and n is the last term. This is the representation of the sigma representation or compact representation of the series. Okay. Now solve some examples on sequence and series. First one is write the first three terms in each of the following sequence defined by the following. First one is write the first three terms of the given sequence. It is defined by an is equal to 2n plus 5. This is the general term of the sequence or series. So an is equal to 2n plus 5. We have to find the sequence of the first three terms of the sequence. This is the general form of the sequence. We have to find the first three terms of the sequence. So first one is an is equal to 2n plus 5. First term is a1. So n is equal to 1. We have to put the n value as 1. 2 into 1 plus 5 is equal to 2 into 1 2 plus 5 is equal to 7. So first term is 7. Second term is a2. n is equal to 2. We have to put the n value as 2. 2 into 2 plus 5 is equal to 2 into 4. 4 plus 5 is equal to 9. And the third one is a3 is equal to 2 into 3 plus 5. So is equal to 2 into 3 is the 6 plus 5 is equal to 11. So the first term of the given sequence is 7, 9 and 11. These are the first three terms of the given sequence. The general form is an is equal to 2n plus 5. Okay, next one is an is equal to n minus 3 whole divided by 4. We have to find the first three terms of the given sequence. What is the general form of the given sequence? That is an is equal to n minus 3 divided by 4. Okay, we have to find the first term as a1. So a1 is equal to means n is equal to 1. 1 minus 3 divided by 4 is equal to minus 2 divided by 4 is equal to minus 1 divided by 2. 1 is a 2 2 is a. Okay, second term is a2. We have to put the n value as 2. Okay, so 2 minus 3 divided by 4 is equal to minus 1 divided by 4. Minus 1 divided by 4 is the second term. Similarly, the third term is equal to, the term is a3 is equal to 3 minus 3 whole divided by 4 is equal to 0. 3 minus 3 is equal to 0. 0 divided by 3 is equal to 0. So the first term is minus 1 divided by 2. Second term is minus 1 divided by 4. And the third term is 0. So the first three terms of the given sequence is minus 1 divided by 2, minus 1 divided by 4, 0. These are the first three terms of the given sequence. Okay. So, next example is what is the 20th term of the sequence? It is defined by an is equal to n minus 1 into 2 minus n into 3 plus n. They have given a general form of the sequence. We have to find the 20th term of the given sequence. It means n is equal to 20. N is equal to 20. So we have to find the a20th value. A20 is equal to 20 minus 1. We have to put the n as a 20. So 20 minus 1 into 2 minus 20 and 3 plus 20. Okay, then is equal to 20 minus 1 is equal to 19 and 2 minus 20 is equal to minus 18 and 20 plus 3 is equal to 23. So the product is plus into minus 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 into plus minus. So the value is 7 8 double 6. A20th value is A20th values of the given sequence is minus 7866. Okay. The sequence A and B defined as follows: A1 is equal to 1 and An is equal plus 2 for n is greater than or equal to 2. Find the first 5 terms and write the corresponding series. They have given the general form of the sequence, that is an is equal to a of n minus 1 plus 2, and also they have given a first term a1 is equal to 1. So we have to find the first 5 terms of the given sequence. So they have already given the first term. We have to find the remaining 5 terms. Means a2 is equal to, so we have to put the values of n is equal to 2. So a of 2 minus 1 plus 2. a2 is equal to a of 2 minus 1 is a1 plus 2. They have already given the values of a1. So it is equal to 1 plus 2 is equal to 3. We have to find the third term. a3 is equal to a of 3 minus 1 plus 2. So is equal to a of 3 minus 1 means a2 plus 2. We have to already find the values of a2. That is a2 is equal to 3. 3 plus 2 is equal to 5. Similarly, the fourth is a4 is equal to a of 3 plus 2. Similarly, so a3 means we have already find the values of a3. 5 plus 2 is equal to 7, and a5 is equal to a4 plus 2. So a4 means 7 plus 2 is equal to 9. So these are the 1, 3, 5, 7 and 9. These are the first 5 terms of the given sequence. So 1, 3, 5, 7, 9. These are the first 5 terms of the given sequence. Then we have to find the corresponding series. The corresponding series means sum of all the terms of the sequence. So is equal to 1 plus 3 plus 5 plus 7 plus 9 is the required series. Okay, students, we shall continue with the remaining part. We shall continue.